Hello and welcome to my final mini project on simulating a Martian sandstorm. Let's get right into it. The objectives of my project for characterization was to visually demonstrate the key differences between sandstorms on Earth and on Mars using Unity3D particle system force fields, and landscapes from respective locations. The analytical objectives are to conduct a visual comparison of sandstorm heights on Earth and on Mars, while investigating wind velocities required to initiate and sustain sandstorms on Earth on Mars, and examining atmospheric density during sandstorms and its influence on the behavior of particles, where the visualization objectives were to accurately represent the information in the literature review and capture the aspects of analytical objectives under Earth and Martian conditions. The project workflow from start to finish consisted of data collection from NASA 3D resources and open topography of a region within the Mojave Desert. And I did not actually use the Unity dust particle data package. I just actually established a dust particle within the particle system within Unity. After that, I used Cloud Compare to convert those into FBX files that I uploaded in Unity and then placed a particle system beneath the Martian and Earth topography to simulate sand particles, or dust particles. After which, I established force fields in both environments to simulate wind, and I referenced literature to establish realistic scenarios for both Earth and Martian sandstorms, where I then implemented the respective values to the particle system components as necessary and observed the results of the simulations and modified as necessary. I did not actually use values that were presented in research, as the conversion to what this would really entail in Unity is not clear, and it is really just based on me to interpret. So, in any case, the point was to establish a visualization of what a Martian and an Earth sandstorm would realistically look like or hypothetically look like within Unity. So that's what I based my project workflow off of. This is the Earth Sandstorm project output that I made in Unity 3D using particle systems and particle force fields. The color by speed is red, so you can see that how much influence the particle force field system has on the particle system, or the particles being emitted by the particle system. As a result, to get it to actually be uplifted and then placed into motion so that it actually moves the same way a sandstorm would on Earth. I also used a gravity modifier on the particle system, and not the, well, actually on the particle system force field as well, but on the particle system to simulate like the real effect of gravity on particles, where on the particle system force field, gravity would actually kind of work in the opposite direction for some reason. I had no idea why, but yeah. In any case, you can adjust X, Y, and Z values within the particle system force field. Here, it is outlined with blue as a box. So that's just kind of how it looked like, so I could get this effect. There's also a hemisphere option. Didn't opt for it. Didn't work. Even though it would be more realistic, I think just the scale would have had to been much larger, and I couldn't get the output I intended or wanted, um, based on what I saw in the literature. So um, the only reason why this can't be more widespread is because there's a maximum amount of particles, and to establish sort of like this dusty effect, the duration of the particles within the system can only last so long, even when it's looping, just because they're the particle system keeps emitting it. So, and then it also just causes issues with it actually lagging. So every single time I make a change to a particle system or the particle system force field, it will just continuously just want to reload everything, and it just took way too much time. So with these settings, I could actually effectively simulate this sort of phenomena. The external forces enabled the effect of the particle system force field. Collision is enabled, so it can interact with the FBX file, so the Mojave Desert region landscape. mesh collider as well to facilitate the collision. And there are my particle system force field values. So it could actually simulate the effect of wind. And that's more or less it for this. My output for the Martian Sandstorm, I think it's kind of obvious just that even at the beginning, it goes a lot higher. So that's what it's supposed to look like in theory, but also based on data that we have from MDAD and remote sensing on Mars. So it goes a lot higher as a result of the atmospheric density. So basically, I just used a higher Z value within the particle system force field to simulate that effect. Most of the particles converge before going to the maximum height of the sandstorm. I tried fixing it, couldn't really do it, and I can't tell you why that's happening. So that was definitely a limitation for what it could, in theory, really look like. But the particles themselves for the Martian sandstorm are a lot smaller because that's just how Martian geology is in comparison to Earth's. Most of the settings are basically the same, except I just changed the amount of emissions. So this one's 1,000 in comparison to 500 because these particles are smaller. So this will grant it a more comprehensive way to visualize this phenomena. Same thing with the color by speed. It still takes a substantial amount of energy or wind velocity to put these particles into motion or in flight. However, granted, with the atmospheric density of Mars, I put a lower value on the gravity particle system to reenact this actual effect that it could have. So it can go higher, not only with the particle system force field Z value being increased, but also with a lower gravity particle system value as well. And I also used a box for the particle system force fields. And that is more or less it. So there you go, Martian Sandstorm. The implications of this project: by simulating and studying Martian sandstorms, researchers can assess the potential risks and hazards these storms may pose to equipment and human space exploration. Factors such as particle size distribution, wind speed and direction, visibility reduction, and the potential impact on equipment could be derived from these visualizations. The implications of the various factors purely through visualization can provide insights on the unique characteristics of Martian sandstorms. Thank you very much. And there are my references.